Hello friends, welcome you all to the next lecture of the JC Connect series of online lectures. We are into module 5. In the previous lectures, we have discussed about anchorage zone, understood the requirement of the anchorage zone reinforcement, and also designed the required reinforcement. Now, in this video, we will be studying the next concept, which is transmission length. Now, what is the meaning of transmission? Transmission in a sense means transfer. Transfer of energy, transfer of force, transfer of stresses. Now, in case of our PSC section, especially the post-tension sections, the transmission word is connected with the transfer of stresses from the anchor zone to the span of the member. This transmission length becomes a very important factor because through this transmission length, the entire stresses which are applied on the tendons are passed on to the concrete in the span. Hence, let us try to understand what is this transmission length concept. So, let's start with the definition. The distance required at the end of a pre-tension tendon for developing the maximum tendon stress by bond member is called the transmission length or the transfer length. It is denoted by LT. Okay. So, when the pre-stress is applied at the jacking end, it is not that immediately the pre-stress is transferred over the entire section. It requires the proper bond through which the stress transformation takes place. So, the initial length which is required to carry out this transmission of stress over the span is termed as the transmission length or transfer length. So, this is done by the bond between the steel and concrete. Steel in the sense the PSC tendons or the wires which are stressed. The stresses are induced in the wire which are further transferred to the concrete through the bond, and the total length of the section required to carry out this transfer or transmission of the stresses is termed as the transmission length or the transfer length. It is denoted by LT. So, this region or this length plays a very important role in transmission of the stresses from the jacking end to the span. Hence, the features of this zone or importance of transmission length has to be understood. Now, when the transmission length, what happens is there is a gradual decrease in the diameter of the tendons, giving it a slight wedge shape over the length. This wedge shape is referred as Hoyer's effect. Hoyer was the scientist or a civil engineer who did research in this field, and because of his research we are able to establish many conclusions. Hence the name Hoyer's effect has been used for this phenomenon where the tendon takes a slightly wedge shape. Now, this question of transmission length has been repeated 2 times in the previous 3 papers. So, theory question also is asked on it. It is there in the code book, but the way you present it in your answer sheet will matter. Directly you should not copy and paste from the code book. So, this paragraph and the next slide will be useful for preparation of your theory notes. The transmission of pre-stressing force from steel to concrete is generally through a bond comprising of adhesion, friction, shear resistance. At the intermediate point along the length of a beam, the bond stress is resisted by adhesion, while in the transfer zone, the tendons invariably slip and sink into the concrete, destroying most of the adhesion. Consequently, the bond stresses are reduced due to the friction and shearing resistance. The maximum bond stress is reached in the zone of transverse compression when the bond stress is 0, the stress in steel and concrete reaches their maximum value, and uniform stress distribution is prevailed from this section. The length needed for achieving this is termed as transmission length. So this paragraph clearly explains you all what is transmission length. When the stresses are applied, the stresses are transferred from the steel wires or the tendons to the concrete, and this transmission takes place because of what? Addition, adhesion, friction and shearing resistance. But the bond strength factor is the most important thing in this transmission. So over a length, because of this bond stress, the transfers takes place, and at a point this bond stress becomes 0, where the stresses in steel and concrete reach the maximum value. Maximum value means the applied pre-stress. Okay, the applied pre-stress is achieved at a particular length. Now in this, few losses takes place, as we have studied the losses in the previous chapter, anchorage slip, okay, adhesion and all, those all factors come into picture, and the required effective pre-stress is transferred from a certain length and is continued beyond it. So that particular length which is required to achieve or to transfer the required stresses in steel and concrete in case of PSC members is termed as the transmission length. Now, factors governing transmission length. So it was a 6-mark question in one of the previous papers. This is available again in your code book. The PSC code book is very small. If you go through it, you will get it. But it is not presented in the way I have typed the points. So it is always better you follow this. So let's discuss the factors which govern the transmission length. Generally, it will be a question in which just you have to note the factors, but with your common sense and general knowledge, technically if you are able to explain them or say write one line about it, it adds up to your answer. But basic thing what you can do is mention these 10 factors which are governing the transmission length. So first is type of tendons. So it depends, either we are using wire, strands, or the PSC reinforcement is in terms of bars. Then size of the tendons. Next is stresses in the tendons. Obviously, if the stresses are higher, it may take a longer transmission length to transfer the stresses to the span. Then is the nature of the surface of tendons. This plays a very important role. So the nature of the surface can be plane, indented, twisted or deformed. So in case of twisted and deformed, we can achieve a higher bond strength as compared to the plane reinforcement or the plane tendons. So if you have higher stress and you want to minimize the transmission length, it is better you go for twisted or deformed tendons. Then is the strength of concrete at transfer. So FCI. So generally what we take is FCI or FCK value, but as the transfer moment at which the stresses are transferred, say at the end of 7 days, okay, so FCI value plays a very important role. Generally FCK value is the one which we take after 28 days, but if the transfer is carried out after 7 days or the 11 days, the FCI value is what is important. Okay, so strength of concrete at transfer plays a very important role, because higher the strength, higher is the bond stress. Okay, you get a better bond with a higher grade of concrete. Hence the strength of concrete at transfer is a very important parameter which governs the transmission length. So next is pace of cutting of the tendons. So if you see the process, how the tendons after stressing they are cut, there are two ways. Either they are cut abruptly, means suddenly by using flame cutting, or gradually the jacks are released and tied. Okay, so the transmission length also depends on this factor. Next is presence on confining reinforcement. Okay, if you have a confining reinforcement, it also impacts the transmission length. Then effect of creep comes in, compaction of concrete. If you have a highly compacted concrete, the bond stress is higher. Okay, you'll get a better bond and it will be easy for the transmission. Then next is the concrete cover. So concrete cover is also an important factor which governs the transmission length. So these are the 10 points. Generally list the points is the question. Okay, these all points are available in the code book, but they are not written point wise. Okay, so it is a better thing that you write the answer as 10 separate points. Now let us discuss some recommended values of LT, that is the transmission length, as per IS 1343. The following values may be used provided that the concrete is well compacted and detailing is as per the relevant provisions and standards, and strength at the transfer is not less than 35 Newton per mm square. So under these scenarios, LT can be taken as 100 times of the diameter for plain and intended wires. For crimped wires it is 65 times of the diameters, and for strands, okay, it is 30 times of the diameters. Now your strands are generally something like a twisted bars or a HYSD type bars. Okay, so there you can achieve this transmission length in a shorter span, whereas if you check for plain bars, the transmission length span increases. But these conditions are applicable, okay, with well compacted concrete, detailing as per the codal regulations, and if the FCI value is not less than 35 Newton per mm square. Now this can be your PGCET question also. Okay, when are the values of LT as per IS 1343 applicable? When FCI value is not less than 30, 35, 40 or 20. Okay, so these points, whenever the codal reference comes, this can become a type of a CET question for you all. So please note it. So next, even the codebook gives recommendations to avoid LT, avoid in the sense minimize or reduce the effect of LT, because if LT is higher, the span length goes on reducing. So let's see what does the codal recommendation say. For general guidance, it is recommended that 1/2 of the transmission length shall overhang the support in case of a simply supported beam, whereas in case of a fixed beam or the whole of the transmission length shall overhang. Now when we look at the supports, say if you have a simply supported beam, what it says is the overhang means the beam which is resting, or say bearing. Okay, what we have generally termed this as bearing. It should be minimum of half of the LT. Okay, so bearing length should be minimum of half of the LT if the beam is simply supported. Now if we have a fixed beam, okay, if we have a fixed beam, or generally it means it's a continuous beam, so in that case, okay, the LT should be taken as entire, okay, entire length of transmission should be covered over the support. It is recommended. It is not that it can be achieved every time, but these are the two things which IS code recommends to reduce the transmission length. If the transmission length is reduced, the effective span length is higher and the beam can be taken for carrying more heavier loads comparatively. So this is what is LT, or the transition length. This concept we will continue in the next lecture also. Please go through the video, make your notes so that the next lecture will be easy for understanding. Thank you.